And it's started, okay. All right. Yay, we want to do BIP. But before we do BIP, I had given everybody an assignment to try to code up your own, how to launch our art software. How many people got something to work?
Could you say what you said again?
So we wrote the code for art last time. And I said, before you left, we had that slide on how do you call it. I said, hey, try to write your own thing to launch it and we'll compare and see how you did.
Yes.
So how many people were able to get it to run and look at stuff? Yes?
Mine's a little noisy, but it's close.
Yay, everybody, did you get something to run?
Not really. I tried, but
So where was the difficulty? It helps me know what information to give.
hold up, MATLAB's still pulling up.
Yeah, no worries.
I think it, I don't know. I'm trying to remember what I was trying to do.
So I'll explain mine. It should be somewhat similar to yours, but we'll have a little difference. Yeah, mine's got to look a little bit different because I wanted to actually plot, and I'll show you where the plot is on mine. I'm just making an array of simple integrations. That's the way. Did you get up?
Yeah.
So what part was that called? Don't worry about this yet. This gets into even more advanced stuff. Just where yours had. Like, were you able to get all the data you needed to call it?
Yeah, I was able to get that. I think it was just, there was some like extra stuff I just didn't know to add. And so I couldn't actually get like an image or anything up.
Okay, so which stuff? Again, it's not, I mean, don't worry about whether, we just want to get to where the right answer is. I want to make sure if there's something you're missing that I backfill the information.
Yeah, I think it was, I think I might just be a little confused on some of the different calls and things like that and what they actually mean.
Okay, well, let's talk through it because I just want to make sure it makes sense. And one of my fears is when there's code to look at, right, that's known right, it will automatically feel right. Because when you know I wrote it, you know it works. I've generated images from it, things of that sort. It will lower your ability to remember in the future. So it'll make sense now, and then in like a day or two, it'll be like, what the heck did you do? So, I'll talk through what I did here. And I tried to make mine a little bit fancier because I wanted to, bad me. This is what I generated. That's what mine does. It just, so I started from 0 and it generated this image and then it keeps going down and you'll see it's getting clearer and clearer. Right? So I just wanted it, first iteration, second, third, fourth, fifth, sixth, seventh, eighth, ninth. And that's as much as I could fit on a paper. That's all I needed. But it's as much as I could fit before they got so small they were useless. Right? So that's what I was trying to achieve with mine. Okay. So some of these things, actually, let me kind of walk through. I'll highlight here on the computer some key things. There's some intro areas that everybody should have on theirs. So first off, we need an image. All right. It won't let me select them. So the first 2 lines here, right? All I'm doing is I'm saying, how big do I want the image? And what is that image? And this is just our standard kind of phantom area, right? Then I have to get a radon transform of it. to give me my sinogram. Because remember, the radon transform is kind of like a perfect mathematical world CT scanner. So no noise, no nothing, it just perfectly does what you're supposed to do. So it's a good model for what a high quality CT scanner will do. So I have to tell it how many angles. 0 to 179 gives me 180 degrees, that's steps of 1. That's usually about as good as a medical scanner is going to give you. Too much beyond that is usually not worthwhile. Then I calculate the radon transform from that, I get my sinogram. Then I just find the size of that sinogram, because remember, we're going to need the size of the sinogram to set some of the other parameters up. Like we need, to set up other errors. Anyway, the X0, I set that up. Remember, we want columns when we vectorize our X0 guess. So I literally here just guess zeros. So I'm fill it with nothing. There's no presupposed. Now, in reality, it would be better to start with something, but if you notice, it converges pretty nicely even without it. It just goes even faster. Usually, if I start out at 0, I'll get to about where a decent thing would have started after one, maybe 2 iterations, 3 iterations. So it saves you a couple iterations if you have a good starting condition, and we often can get that fairly quickly. Right here, I set iterations to 1 because remember, inside our algorithm, we could let it do it. So if you had to imagine you want a similar type of a setup here where you were wanted to see samples at various points, but it was one of those other systems where you had to take slower steps. So you maybe had to do 200 iterations, but you're only getting that. So you might want to do something like 20 at a time or something of that sort. So I could say iterations 20, and then you get like every 20th iteration when you're walking through them. So anyway, that's just right here. I don't need more than that. To calculate the rows, that's how big your A matrix is going to be, or you can think of it as the when I'm reordering stuff. That becomes important because I have to give the order that the rows are going to come in. So I mentioned this part right here is actually just for the reordering. And I made the comment to you that there's this kind of cool result from numerical theory or number theory, truly, where it's essentially 2 numbers, if they're mutually co-prime, as I'm walking around in a modular sense, it'll walk through all possibilities before it comes back to the original. So 0 through rows minus 1 times prime is going to be if I just added prime, I started 0, add prime, that's when it's 1, add prime again, 2 times prime, so on and so forth. Right? So that just gives you a sequence of n times prime. When I divide by rows and take just the remainder, right? That's what mod does. That sequence is guaranteed to go through the numbers 0 through rows, not repeating anything, or 0 through rows minus 1. So that's actually a nice one, as long as they are. And I picked a couple different, these are all prime numbers. So I just left them there in case you want to try a couple ones. You can switch through them. You should really pick it, to be somewhere near, like we had said, maybe a 6th or a 7th, something like that. I don't remember exactly, but I thought this one had something like 40,000 or something like that. I could be off on that, but I thought it was something like 40,000 total that it had to go through. So that's why I kind of picked these ones. It's maybe a 10th or something like that. Something like that. So anyway, and this was pretty close to like a 20% or something. So it seemed like reasonable numbers, but you can try different ones if you want to grab a couple primes. If you just look up there and on Google or whatever your favorite search engine is, primes, you'll get a whole list of them. So, and so this is just that setup for it. The relaxation and forgetting, I gave you, there's no rule. So these are approximate heuristics that I use. Alright, so this is literally, this is not a hard and fast thing, and I change these heuristics based on some general size parameters. For something around, 200 with, a minimum number, which is what this is going to give you, a minimum number of, reconstruction histories to produce this. These are pretty much in that range, right? So I picked my relaxation parameter to be proportional to my image size. So 0.1 over square root of n seems to do a pretty good job. In this case, you're going to be somewhere around like 0.04 or something around there. It's a pretty reasonable number for this size of an image. The forgetting factor on this, so forgetting factor is relaxation parameter can change all the time. Generally, when you first do it, you want a larger relaxation parameter because you have more distance to go. Right? So you want that number to be bigger so it takes a bigger chunk of it. Right? As you get closer and closer to the solution, you can take smaller and smaller steps and you want to kind of polish it. So you don't necessarily want as big of a step. So this one sets the forgetting factor for this size thing somewhere around 0.85, something like that. Right? So you lose about 15%. So it gets a little bit smaller each time. It makes it a little bit less aggressive, so it'll kind of smooth down towards it. You can try different things, set it to 1, set it to a couple other stuff, and you'll see you don't always want to pick relaxation constant. If you are going to pick this one constant, then I pick it a little bit smaller to start. And anyway, that's some ideas, right? The distance, again, remember that's how wide around the line you're going to do. And I said you probably want a minimum of 0.7 given the diagonal, right? So somewhere between, say, like 0.7 and, a little bit over 1. So I kind of split the difference and picked 0.9. I'm not saying it's magically the best. I just kind of picked somewhere in the middle of our range. If you want to think on the straight up and down, your worst case scenario is going to be 0.5. And the biggest one will be on the diagonal, and that'll be, square root of 2, 1.4. So again, 0.5 to 1.4, that's the other kind of range zone on this. And again, 0.9 is right kind of smack dab in the middle of that one too. So I just picked that one to split the difference. Nothing fancy. The idea of figure, this just walks through the 9 iterations of it. And I start with initially it's 0, I calculate IART, I reduce my relaxation parameter for the next iteration run, and then I have to reshape this because remember x0, it returns an IART that is picture, and I have to make this a vector for the next iteration run. I do the appropriate plot of IART and then just do another image. And it just walks through it and populates that table. And the pictures that I showed you, that's from these numbers. So if you use these numbers, you should get the same exact pictures that I did. Like I said, you can tweak it and get some other ones. So, and you can see, it really is kind of a lot of fun, actually, if you kind of move these around. Try to change some numbers big enough that it starts screwing up. Right? The screw up is actually really important because it will, if you make relaxation too big, try making relaxation too small. Try making forget so small that it drops off really quick, right? Make relax grow so it becomes more aggressive and see how that works. Try a couple different numbers because it'll give you a pretty good feel. Try picking some larger, prime numbers, or pick them in drastically different regions. You can pick one somewhere around 10 times these, it'll still work, right? So my point is just, give yourself a couple variants to see how it goes. Change the reordering so your, prime is really 1, right? It won't reorder anything at all, and see how the reordered ones compare to the not reordered ones. Yeah, the whole point is you want to look at it and see when it does, you get particular shapes or, particular characteristics of them. Sometimes, like if you set it so that it's, believe it or not, too small for an adjustment, you'll get almost a glow on your image. And the reason is it's so small, it'll rescale it back up when it does when you do the matte to gray. And so you're taking small numbers and rescaling them. Small numbers means the error is going to be a significant portion of whatever you've got. And so essentially the glow is just the noise being amplified back up off of them. But you'll get a lot of these different things. You'll find out if you set it too aggressive, you'll start getting the arc lines from the rotated imaging area. So I would just suggest, I don't want to do that right now because I don't think we have enough time when we have to convert to bit. But I want to give you some ideas for how to kick the tires on this so that you can kind of see them. And again, it's because you have to develop your own sense of what works. Now, this is not just for medical imaging. If you do any optimization routine that is an iterative optimization, and these are really common, like if you want to have a nonlinear solution and you're trying to iterate down to it, a similar type of behavior is going to happen on it, right? You take small steps as you move towards where is the optimal. How do you tune those, optimum seeking ones? It's a similar type of a process. So you just want to get used to how they work. We feel good with this? Okay. Hopefully we will have some time at the end. We can actually start playing with numbers here. And I'm fairly confident because this is going to be a much easier one because you've got your existing code and you can actually steal pretty shamelessly. So what I would suggest at this moment is just take your art and copy it, make a new file, and call it BIP. And then change it so it says BIP, and then we'll modify art to become BIP. Because I'd say they're going to share probably a good 70–80% of the code will be exactly the same because they're both projection methods. So don't expect it to be a gigantic change from here. Okay. I'll give you a sec to do that and then we'll talk. So we can first get the pictures and then everybody good? Awesome. So this is just a reminder of how BIP works. So unlike before, right, we take our first projection and we're going to take a subgroup, a number of the blocks, right? And we're going to take those blocks, however many blocks we want to break it into. In this case, I think I had originally, 6. So I broke it into 2 groups of 3. So in this case, I've got 2 blocks. So I took 3 of these ones and I project to each of those. And then I take the weighted average. Right? Again, remember, weighted average means I basically add all of the vectors, right, that I'm getting on here. I take each of those, I add them up, right, and then I divide by 3 because there's 3 of them. That gives me the central weight. You could pick other weighting schemes, but this one is arguably as good as you're going to get. So anyway, we just take that and then that becomes our new offset. So x0 plus that new offset gives me my new vector. All right. We then just take this and we go to the next block. So just think about it, right? I've got to split them in some sense into intelligent blocks, right? I might have to walk through one block at a time. And then inside each block, I might have to calculate each projection and then weighted sum them up, right? So here's an example. The second one, I then take the previous one's answer, the x1, again, project it to the next block's areas, weighted sum them up, and calculate the next iteration. And that gave us our code here. So a lot of this is very, very similar to what we had, There's your residuals, exactly the same as it was before, right? And notice in this particular case, right, when I'm doing this iteration inside here, this is the weighted sum. So notice that the xk, that's the previous step. So when you calculate each successive one of these residuals and you get projection, you're not going to change xk. That's always the previous step. So we're in essence going to have to add up these weighted sums and then add it to the original, right? So it'll still be, you know, x next is equal to x last plus lambda times a weighted summation. And then inside here, this is just what we did with art. That's just the weight, and we just average them all together. Make sense?
I have a question. Should we do this not changing the art code, but just feeding it different portions of the sonogram and waiting what comes out?
So the challenge is there's an iteration inside there.
Right.
Plus, if you just gave it art, remember art does, I probably should have included the art one in here. Where am I going? There it is.
I mean, I think you'd have to run art on each section of the sonogram and then weight each of them.
The problem is that there's two basic extreme cases. One is art and one is Chimino,
Oh, I see.
right?
Okay.
So maybe if you think about here, actually, let me just go back to the last one. Right, so in this sense, right, it does next. This is kind of like an art sequence going on here. What happens at each individual step, this is a Chimino on that subgroup. So if you wanted to actually do that, what you'd have to do is write Chimino code and then call Chimino code successively on a subgroup. That would work. Right? Yeah. If you ever do SAP, I didn't put that on here. If you do SAP, that is actually successive art.
Yeah, that's the one I was thinking it was, but it's the other one.
Yeah. So I deliberately picked this one because it's more pain in the butt. Right? And my feeling was do the more difficult one because you'll find this is still not a huge modification. Which means that any of the lesser ones will be even easier if you ever have to or want to do them. That is a very good question, though. All right. So this is just means break up your original set of everything into groups. All right. There's M of them in here. This one just means it's got to be cyclic, i.e., don't overcount, don't multi-count many things. And this has to walk through the full cycle, and all of your weights have to add up to 1. Right? Other than that, the only thing we've added is this, really. As far as art is concerned, we added up a weighted sum. Right? So you just have to put a weighted sum code. What does a summation code mean? When you see that sigma, what should you think program was? For loop, right? And to do a weighted sum, how would I have to do, some type of, or even just a sum across some loop?
You have to keep one variable outside the loop and keep that into.
Yeah, so I have to have some variable I'm gonna hold into, and I'm gonna have to set it to 0 initially, and then inside the loop I have to add them all back up, right? And then on the outside for the weighted thing, I then have to multiply by the weight. If I knew the weight in advance, I could multiply it inside the sum also. So if we had decided we're going to make, and this technically means you make the weights whatever you want, that's why I get the polytope. You could make a whole vector that just had all the weights, and as long as the vector sum was 1, you'd be golden. Okay, we feel good with this? Okay, the next thing is just going to be our art code. So what I've noted here, this is your art code that we finished last time. But what I've highlighted here are some things that need to change, right? So And like this, for instance, is just your regular thing. This is just you walking through each of the rows one at a time. We need to change that into going through blocks, right? Now, I need to walk through the blocks, and then each block walk through every one that's part of that block. So instead of a for loop, what am I gonna have to do?
Define your blocks first.
So I'm gonna have to have the blocks, and I'm gonna, which means, let's say I had 10 blocks, right? What will I have to do to walk through every single row by walking through the blocks and other things inside them?
Yeah, make sure all your blocks have all the correct components.
Okay. I agree. What else? What will the code look like for it? Will it still be a single for loop?
You need one for goes through blocks and one for
So it's gonna have to become a double nested loop. So the single loop, this single for loop, is gonna have to split and become 2 for loops. Does that make sense? One to walk through the blocks, and the other one to walk through the rows per block. Does that make sense? So that's gonna be here. How about the order? Right? We said before that order, right, was pretty crucial to our sequence. But I want you to look for a sec at the picture on here. How significant do you think it is if I went to the dashed group first versus the second group? Do you think it matters which one of the projections in the first or the second group I do first? Yeah, I mean, because these are all parallel, right? Because I do them independent of each other, so there's no build. And since I'm averaging them out, you're going to expect it's not going to be as aggressive a change, right? And so even when you reorder them and then you average them, it smooths it so much that you're not going to get an awful lot out of it. So the basic point of that is, does ordering matter?
No.
Not very much at all, so why do it? So we're not going to reorder. That's really, so that's why I kind of highlighted that one, is just to think, you can do it, you'll just discover it's really a waste of time. It's a big improvement under Art. It is not, it's zero improvement in Chimino, and therefore in anything that's a decent amount of Chimino, it's basically wasting time. Okay. It will make a little more sense on SAP, because inside the loops, right, you can get improvements. But then you average them afterwards, but you can get big improvements first. So it makes more sense for ordering under SAP than it does under BIM. Okay, how about for this area here, right, where I've kind of highlighted where we calculate it? Portions of that are probably going to need to change too. Do I need to recalculate my residual? No, residual should be the same. How about that updating step? X next, this X last plus relax.
Well, you're going to need to figure out all of them from the weight. So you can't.
So I have to do a weighted average first. So this is going to have to be split into 2 parts, right? One part that's going to come later, which will be X next equals X last plus relax times the weighted sum from that block, right? So I have to do one thing that calculates all the projections as a weighted sum, and then another one that uses that new weighted sum to do the updates. So I have to kind of split it into 2 halves. Does that make sense? So this will change, right, inside here. That's really the only things that need to change. Everything else is the same. I mean, all the setup in here is basically exactly the same, right? As a matter of fact, even this part down here, exactly the same. Because all this is doing, this is just figuring out which particular ones it went through. Things go through the same exact series, right? That doesn't matter how you split them up. This is just figuring out what the row looks like. You're just picking rows in different groupings, but it doesn't change how a photon moves through a particular section. So, you know, these areas are not going to, like this is not going to change at all. That's what I was saying. If you look at it, there's really, you're going to be able to get an awful lot of very similar bits of code. You know, we'll have to add, when we split this up, we'll have to do a couple funny things with it, stuff like that. But overall, very, very similar. Okay. So, this is now my hacked down code, right? I've removed some stuff and things of that sort. Oops, I missed an extra cut here. So let me start from here. Let me ask you before I show you what mine is, right? Try to take this and see how you would take this and rewrite it, right? So first off, which one needs to go first? Blocks or the row or the particular rows inside the blocks?
Blocks.
So you need the loop first. So let's assume we're going to pass an extra parameter here, which will be blocks. Right? And we're just going to say, they'll pass us a number of how many blocks they want us to split them into. And we'll split them into intelligent blocks. Okay? So do that change first. Okay. Then what we want to do is figure out how do we want to split up the rows amongst the blocks. Now, where's my pen? I left it over here. So let's think about how we might want to split up these lovely little rows into groups of blocks. So I'm just going to do a 3x3 grid here for a second. All right? And imagine initially we had this coming through. Maybe we had 5 just so we have some extra on here. All right? Now, what might make sense, like if I was going to split this into, let's say, whatever, 3 groups or something, right? I've got these 5 and I've got the next groups coming in and whatever else, right? Do we want to kind of go take them in sequence? Does that seem to make sense? Would it be better to, you know, grab one of these and then grab something diagonal and stick it in a group?
Could probably do a similar prime logic thing.
Yeah, so in some sense we want to have each of these is kind of produce an image on its own. And then we're kind of averaging the images together in some sense. So we want them, in some sense, we want to make reasonable breakups that are kind of similar looking groups. So therefore, if we do this, it would make sense to put this part of, let's say I had 3 groups, group 0, 1, 2, 0, 1, and then I could go to the next angle and split them up, right? 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, right? And then I would go to the next. Does that make sense as a breakup group? That way everybody kind of gets similar types of history. And obviously as you get to larger and larger images, you know, this is like a 200 by 200, I'm going to break it into 10 groups. You're going to get a lot more, you know, a lot more of each type, right? You'll get 20 of the straight in rows, 20 of the 1 degree, so on and so forth. Does that make sense as a way to group them? So how can I, is there a nice easy way to calculate this so that I can say what row is going to be in a block?
Can you just use the MATLAB colon vector maker?
Yeah, so we already have this, you know, for instance, like for block, right, is equal to, let's say, 0 up to however many blocks they give me, right? I don't care what you do, but like, let's see. So when I get to this inner one and I want to pick my groups, I already know my block, right? In this case, it would be like 0, 1, or 2. Right? So, and this is in C, right? Index-wise, this is my 0 element, my 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. How can I convert from my original row index, right, to being able to figure out which one is in my group? Does that make sense?
You could start at your block number and then step through the constant step size.
Okay, so if I did a for loop for, let's say, my row number, I could, for instance, start with whatever my block number is. Does that make sense? Because that would start me here. If I was on, block 0, it would start me with 0 being my first element. That's good. If I was on block 1, 1 would be. If I was on 2 in block 2, my element would be 2. All right? How do I get the next element, though?
Add how many blocks there are?
Yeah, right, because 0 goes to 0. Well, the next group in 0 is 3. So I went from 0 to 3. Right? The next one that's in 0 is 6. Right? The next one in 0 after that is 9. So I have the sequence for block 0 of 0, 3, 6, 9. Right? This is my block 0. Right? Block 1, if I were to take that one, block 1 has 1, block 1 has 4, right? Block 1 has 7. See the pattern? Give me a for loop. All right, so get both of your for loops in, and then we'll take a look at what we do next. Good? Yay. Okay, so this is what I did. All right, block 0 up to blocks -1. So I didn't put that up there, but it has to be blocks -1. All right, otherwise you get one too many blocks. You do want to make sure you do the 0. The other thing that's important to notice is this one was after the for loop, and now it's kind of in between. All right. Would it still work if I put it down here? If I put it after both for loops?
You have to hold it somewhere inside.
Yeah. And you want to hold your last is constant for an entire subblock area. So you don't want to change it with every element inside the block. So as long as you don't change next, then you're fine, right? But it'll be slow. You'll have unnecessary extra memory transfers. If you put it here, then it reduces the extra memory transfers and also removes the chance that you accidentally screw something up. Make sense? Okay. And then again, the same thing, right? Row, just like we said, block, right? You have to step by however many blocks you have in here, and you go up to however many rows you have -1 inside the A matrix. Yay. Right? And you'll need, of course, the 2 ends now instead of just 1 end. Because it had 1 end before, and now it's got 2. I also removed our residual calculations and stuff like that, because we're going to make those different. Okay, so far so good? Awesome. So now we've got to do our residual counts on here, right? Now, I'm doing to hold my summation, right? I could have called this X sum. I just called it X block, so I remember it's the one for the block. I could reuse X next. It would save me memory. But I'm in MATLAB, and MATLAB is inefficient in computations and it's inefficient in memory, so why bother, right? The whole point is to be clear, so I just waste another variable here. You could overwrite x next because you've already stored its value out, and so who cares, right? Why do count?
So you mix your weight vector.
Yes, that's, and think about this, can't I just pre-calculate this?
The weights are the same, I guess.
Right, and shouldn't they be, I mean, shouldn't I have a set number of histories?
Yeah.
So why do the count? So readability could be pretty nice on here. There's one other case. Am I guaranteed that every row will actually count as a legit row though in my calculation? Yeah, what happens if the norm is too small? You throw it out. You see it had no information. How many of those do you have in each group?
Zeros.
Yeah, how many norms near to zero of AI? Yeah, I don't know either, right? So, I mean, so in essence, you could do it, but it makes more sense to actually count them, then you don't have to worry. You know exactly how many non-zero ones are there. And, so this is just now your basic setup, right? Pre-initialize. Notice I removed the else clause, because in the else clause, what do?
Just do the same.
Yeah, do nothing. So, you know, I don't really need the else clause, and it fit better on my page. So I just deleted the else clause because it's literally useless. Right? So the residual we said should is how different is it from your original? It's not, yeah. So these are the only ones you need to do. Right? These are now running some variables. Right? And then I need to use it to calculate my x next. Right? Now, I'm using the first x next to calculate the weighted sum. I guess you could just block it as such. Right? So you could say, but the first line I'm doing to do the weighted sum, and the second one I'm doing to add the relaxation of the projection. So make your changes. Good? See a couple other people still typing. We're good? Good. So, on this one, all I do is have to get zeros. Make sure when you do X block, you set it to the right size. And, again, it is a vector, so make sure you make yours a vector, a column vector. This residual should be exactly the same as it was before, right? And X block, right? All we're doing is just taking the old one and it's a running sum, right? So it's pre-value plus, and then that's just the projection, right? Residual times AI transpose divided by the norm of AI. Technically it's norm of AI squared, but when we calculate that, we implicitly put the square root already. All right, and then we just count, it's count plus 1. Why not put count plus plus?
No, that doesn't do that.
Yes. Right. Still, one of the more annoying things that's out there, right? And then all I do is, right, the first line x next, I just divide it by that weighted sum. Right? In our case, like I said, we'll have tens of thousands of these dumb things. So I don't have any fear that count's going to be 0 because there's just so many elements inside the block. So, yeah, I don't really worry about it. And then I just have x next, it's x last. Again, I can't overwrite that x last until I use it. Plus relaxation times this x next, which is the weighted average of the blocks. So I guess you could have called that block, but the rest of the code is exactly the same. Guess what? You've now taken your art and made better. That's it. And this is a fairly significant change one, right? Remember, SAP is even easier. So, anyway, all that one does is you have to handle the double nest one, but it's regular art updates inside. And then you have to do a weighted sum outside. But easy peasy. We good? Cool. So should be what your final code should look like, which is what we had there. Right. I just removed the highlighting. So how would you call this one? Right? Well, we already talked about the ordering, right? But shall I start with the same initial guess? Right? How many blocks do you think we should use?
Well, I guess that would be optimized for your processors.
You would pick it so that each of that inner loop of the block that's running will fit in memory of whatever system you're using. So if I was doing this on a GPU, I would pick the number of blocks so that the number of elements that are in it fit nicely within the GPU's memory. For REs, let's just pick 10. It's arbitrary, but it's nice. If you have no other good reason, always make sure whatever number you pick to divide by will divide your system into even groups. So I picked 200 by 200, so it's divisible by 10. You got 180 degrees, again, divisible by 10. All of your numbers you deal with will split nicely into the groups, so therefore we don't have to worry about weirdness is happening there. Okay, so I'll show you what my parameters are in a sec, but this is what my BIP output did for it. And you can see again it starts, and you can see it converging in, getting nicer and nicer. And it's kind of hard to see on this, but you can actually see the small little objects on the bottom there coming into focus and everything. So yay, right? Just as a comparison, this was the art one. So they're very similar, but you'll notice there is a little bit of a difference between them. Right? They're not going to converge exactly the same. And they're not going to even want the same parameters. You will see the parameters are drastically different. So let me ask you, what do you think would be some good parameter numbers on this? Just given what we know about BIP from what we've talked about, how big should I start my relaxation parameter? Should it be about the same size? Should it be bigger? Should it be smaller? Okay, why smaller?
Because you're averaging more projections each move.
Okay, so does everybody agree with that?
I know we talked
Anybody
about it.
disagree?
I can't remember which way it was.
I know. So that's why I want us to think about it. Right? Like I said, it doesn't help you to just see my answer, because my answer is going to be good for here, but it will not be correct for a different size, right? It's actually going to be proportional to your size. So when you're picking these, you want to have a gut feel for what they look like. Okay? It will work for a wide range of parameters, but it won't get good. It'll stay kind of in this fuzzy, cruddy outer zone, right? And it'll limit how good it will get to if you pick bad parameters, right? And then you'll be frustrated, like, why is it not converging, right? And that usually just means some of these other numbers are off, right? So having some feel for this is really important. So let's think about what's going to happen for each one of these. Let me try to draw. I'm just going to do this for a little block. I need to stop carrying this pen over here. Imagine this is my two-dimensional coordinates, and I'm going to try to do this twice so that we can show it for art and BIP. So I got here and here. Is that close enough? My pen is dying fast. Is that at least good, somewhat? Okay. How's art going to work?
Just go from line to line.
Okay, and I started at 0. So it's going to go 1, and then 2, and then 3. That's one iteration. How is BIP going to work?
Just 3 lines.
Let's just assume that it's all in one group.
Oh, okay.
Right, so Chimino then, I guess, would be it. Right? It's going to project.
Oh, it'll take a smaller step.
Draw your polytope around.
Such larger components.
Yeah, it's taking a smaller step, isn't it? Now, the more projections you have, do you think it's going to take a bigger or a smaller step? Smaller, yeah. So the more histories inside your block, the smaller your step is going to come. So you would expect I'm probably going to have something growth-wise fairly decent. And it should give me some idea as proportional to how many histories I'm breaking these into as a group. That's fair? So we expected bigger. Now, that means it's going to be pretty aggressive, won't it? So we would expect we might have to use our relaxation parameter, or sorry, our forgetting factor, right? Otherwise, you might get something a little too aggressive. Okay, so here is my calling code modifier. There is essentially no change from here above other than I put a comment that said art, and I put TikTok. What does TikTok do? Right? Just so you get comparison time. It'll tell you, talk will tell you how much time has expired since tick. Now, is this going to be a good measure of my art function? Pretty reasonable, it's in there, but it's got some other crud too, doesn't it? Right, one of which is the plotting routine, which is notoriously slow. So it's not going to be necessarily the best, but it'll be kind of general. Right? I'm going to have to do something somewhat similar to the other one. So at least they'll be comparable in the payment I'm going to put onto it. And this is just stupid easy. So, it'll give you a rough feel. If you really want to do it precisely, you should actually have something where you measure before and after and sum them up across. It's like that, but probably not worth it. Right? Now for this one, notice I keep redefining x0, so you got to make sure you set it back to 0. I set my blocks to 10. You'll notice here I picked this because that's roughly speaking, compared to the old one, amplified by a factor of about how many elements I have inside. So if I took that old number, which was 0.1 over root n, right? And n is basically the size of your image, right? So it's about 1,000 times n bigger. So it's a significant jump up. But notice my forgetting factor, before it was 0.85, now I set mine about 0.75 for this one. You can try, ticking it around a little bit. Other than that, it's pretty similar. Just notice that we've gotten rid of the ordering here because you don't need it, and I've added blocks at the end. So make sure you do yours. Other than that, it's basically the same code, just generate a new figure. And then, like I said, given that situation and picking numbers somewhere in this zone, again, I would kind of split these up a bit. They should be about the same time. Because right now, we haven't utilized the parallelization yet. Right. It's not too hard in MATLAB to parallelize the stuff. There are a few changes. The simplest one is to do what's called a par 4, parallel for loop, inside of MATLAB, which means you change 4 to par 4. But there's a couple other changes you have to make to the code to make it work a little bit nicer. One is, it would be better to pre-calculate your weights at that point, because otherwise it's a loop carry variable, which will cause cross-communication stuff. Second off, par 4 loops do not like the just-in-time calculation of the blocks that we did. That you have to, with a par 4, it has to step one at a time. And we are stepping ours based on the number of blocks. Right? So you would have to actually make a variable where you kind of stuck them all in and then walk through a vector that had essentially that same format of your for loop. You just do one for each loop and walk through that way. But you could it's like a 5-6 line change, and you could parallelize it. Theoretically, if everything was perfect, so I've got parallel to 10, my uppercase would be a 10 times speed up. A lot of my code is not inside that for loop. That's only the inner part of it. That's still probably 90% of what's running. But you won't get 10. It won't even perfectly parallelize because you're adding these up and then it has to average them. And the averaging is not parallel. So, yeah. But even so, you should get, several times speed up instead of maybe say a minute, you'd probably get down to 20 seconds or something. Type of thing if you did that. All right. What I'd like to do now, you've actually got what you need. I want you to try, make sure your code works. If your code doesn't work, I want to help you make your code work. We have 15 minutes left. And then if your code does work, I'd like you to try a couple of these parameters, tune it, and see if you can get it better, and untune it, and see what it looks like it gets worse by screwing up different variables, too large or too small. Does that make sense? Again, and that's intuition. Look at the image and see what it does when you screw up. Cool. So first we'll get it running. Once you got your code running, or if you run into a problem, give me that can all walk around and see. And then hopefully we'll get to some other looking at tuning stuff. How's yours going?
It's having an error with the reshape.
Okay, what's the error? Is it okay if I move this?
Oh yeah.
So what's the error it's calling out?
In line 21, the reshape of the IBIB just says error calling it.
How big is your X0 or the original IBIB? Sorry. Your IBIB is, that looks like it looks like, remember we said if it doesn't get the right size calculating, that it'll kick it back a number to you. That's what it looks like. We got and your image size was 200, right?
Mhm.
So that should give you 200 times 200. So I think it's just telling you that you got the image wrong. Can you go to is that in BIP or is that on?
I think it's might be in art. It would be in both.
Oh. So let's see what we got. So just put a stop, click on 14. It should set a breakpoint. Set modified condition. And then I just want to set the breakpoint once it's done.
Oh, they just set one if I just click on it like that.
Okay. Mine always makes it red. It's whatever. Okay, save it and then let's run it and see what size we have when we hit here. So it should. Oh, it went right to BIP. You on yours? Oh, you. So you're not calling art anymore.
Oh,
You called BIP twice. Yeah, call art all the way through. But don't do the control enter, otherwise, yeah, see it, and it redoes all these for you too. But I wouldn't worry about that later. Let's just run it here and we'll see. Okay, now we're good. Now just click back over here and let's see how big our stuff is. Right? So N is 100. Is that how big you picked yours?
it sits right here, right? Or
Well, how big did you make your image? Yeah,
100.
so you made 100. Okay.
Okay.
So 100 is correct. And then that means that the size of X0 should be 10,000, right? If you just hover over, just make sure. If you hover over, it should put in the tool too. Hover over X0. Okay, it hasn't calculated. Tell it to step. Now hover over X0. Or should I over size of X0? It's 10,000. And then come down here and let's see if columns of A is also equal to 10,000. So that should be good. Okay, click step again. Okay, so that is. So all those are correct. So just hit continue. Look at this. Line 33. Okay, so give us a breakpoint just before, yeah, right on that line. And let's go back and call the column. Okay. Yeah. Okay. So now let's see how big each of these things are. Right? How big is detector? Detector is a 1x1 double. So that should not be the case.
Also, like the first time.
Well, actually, you're pretty good. That should work. How big is AIX?
Breaking or is it just not really doing
It's not giving me an image.
I might have stuff that's
Oh,
wrong in other
so that should not be case, you should be picking one of the angles. How big is angles?
Um,
You should just be able to hover over it, it should tell you.
oh, yeah.
That's angle.
Yes.
Oh, see inside there? You have angles of angles.
Oh, should it be
Angle.
angle here? Okay,
You're picking the angle out of angles.
okay.
So save it. You can probably pick that up. Because probably that was our mistake.
I should do it in both. Oh,
Well, I got through the first one.
yeah, I just didn't fix the other one yet. Okay, so that works now.
It's not too bad. It was about 9 seconds, basically.
Oh, I don't think I fixed this part. Yeah, I'm calling it. Yeah, it says like iron.
But don't, yeah. You don't want to back. But that isn't the particular problem that's there, right?
Yeah. 136. Pretty sure.
And how big is IBIT? It's 10,000. Oh. You're, well, what, let's go down and see what you're returning. Go up there. See how you have both of these together?
Uh-huh.
You overwrite your other one with how many columns were there. That
Okay.
was, the columns of A was the else condition.
Gotcha. So that just gets.
And there should be an else before that, in between those two. Because that was the, if you sent the wrong size thing, we're gonna tell you how many columns of A we thought you should have.
Mhm.
So you can compare it to your X zero.
Okay.
So it literally was just overwriting it with a single number.
Okay. Okay.
It happens, I actually, it can run the whole time like copy and paste. It should work now.
Okay.
How's yours going?
I'm getting these.
Yeah. So remember I said you'll get those way too strong spirals? So that's a parameter misuse. Right? The parameters are wrong.
That's
Yeah, I picked mine, so my numbers, I picked 200 as my size. So this might be a little bit off because yours is a smaller one.
true.
So it might not want it quite that, and you might need like square root of that or something like that.
Okay, sounds good. Yeah, I just made a small version. I just saved all the immediate projections. Pretty sure.
Well, my comment was that it was not necessarily we have to increase the 200, but you'll probably have to change the heuristic.
Right, makes sense, but it would be easier probably just to run with that.
Yeah, so it should give you the same.
Also, I'm just running for blocks for details.
I'll let you know yourself. Okay. I'll be reading it for. Okay. And I'll come back and check. So what's going on with yours?
You guys want to go with my art?
Okay. Unrecognized rows, line 29. So this is going on.
Yeah, it's just on.
So So,
Yeah.
yeah. Because your thing is called row,
Row of rows.
So-
Row.
right there, let's stop, right there.
Okay. Nice.
So save it and see what happens, see what
Okay.
typos are happening all the time.
So this was, well, can I comment all this
Comment on the image,
or
just highlight the whole thing. And then come up here, that comments now, that removes the comment.
sweet.
I'm sorry. Incorrect image. So that's AI transfer. Yes, you did the single quote. Yeah, that means transpose.
Okay.
Because normally it's a row, now you need it to be a column. This way, you got them a whole bunch more, I'd say.
Okay, gotcha.
So it's a complete.
Save. Well, that was just one more error. And, oh, but that's here.
But that's the same old error,
Yeah.
right? So. See how far it gets. Some of these can run for a little while.
Oh, I'm allowed.
And not too bad. Just every 30 seconds.
So I think
Okay, but that was a whole bunch of zeros.
zeros, yeah. I think because I might be missing something.
I'm sure the art was.
That's not a
should-
previous function, is it?
It is.
Oh, it is.
That's a built-in MATLAB.
Okay, cool.
He'd actually type help Phantom and I'll tell you what it does.
Sure. Were you missing?
So usually when I see a completely black image, it makes me think that the rays missed it. Which usually that means you forgot to shift them to the center of the detector. When you go to art.
Mhm.
And where do you? Okay. That's correct. Detect is incorrect. 2 seconds. So small point, this actually has to be row plus 1. Because rows are order and it starts at 0. The very first one is probably outside the edge, so it probably gets the wrong way, so it doesn't block in the face. But you'll be connecting the wrong ones. So you want a plus 1 there. That should not be the problem, I think, anyway. Scroll down. So what I would suggest is we're probably gonna need to check and see if these variables have some correct values in them. On their paths, what we're gonna do is put breadcrumbs in there. How long will that stop when it gets here?
Okay.
Do this over here. Run it. We'll be able to check what they are. Let me just real quick check, make sure everybody else is good.
Yeah, I do have a class,
Okay.
next period, or, you know, like 10 minutes, but, tomorrow.
So let me know when you need help
Yeah.
debugging and we can debug.
Do you think we can do like tomorrow after the meeting?
Potentially.
Okay.
I'll have to check with them.
But also, I put in overtime at Proto Lab, so I should be off tomorrow.
Oh, awesome.
I think earlier too. Yeah.
It should be okay?
I think I'll
Okay.
just play around with some
Yeah.
parameters.
So that is a fairly common situation that happens. Again, it's a little bit too aggressive on your values.
Okay.
Like, you'll get those rings. So you cut it down a little bit, right, by making it bigger. It is possible you might have different offsets than I do too.
Yes.
That big center ring is consistent with an offset. So there. So I would check a couple of those just to make sure. If you run into problems, just try kick it down smaller and smaller until you get to a value that looks good. Although at those numbers, you should be doing similar to.
Right.
So I'd be tempted to think there might actually, I should need to stop the video.
Yes, won't be a